Yeah, we're on 4.5 day 2. All right, so example 1, we got a word problem to start off the day. It says Josiah's putting together supply kits and has 36 packs of P pencils and 12 packs of C crayons and then just 24 erasers. So we know how many erasers there are. So let's write an expression to show the total number of items that he has. So first of all, how many packs of pencils does he have? He has 36, so that's going to be represented as 36.
P.
36P. And are we adding or subtracting? Adding. And then it's going to be 12. What? C for crayons, because he's got 12 packs of crayons. And then 20. Is it 24E? Or is it just 24?
24.
It's just 24. Why is it just 24? Why does this not?
24.
Well, why is it just 24? Why do we not need to label this E?
Because it doesn't say.
Not necessarily. I mean, it says it's an eraser, Foss. It's not packs of. We have a fixed amount of erasers. So it's not a rate. We have our expression here. So letter A, write an expression to show the total number of everything. So that's going to be 1A, right? So we have our expression. 24 does not have a variable. 1B. 1B says factor the expression. So let's go, Josiah, factor it for me. Factor our expression. Well, it's the opposite of the distributive property, right? So you're going to not multiply, but you're going to. There you go. What can we divide by?
Oh, yeah. Okay, now I remember this.
Expand it.
Like 6.
We can go higher than 6.
8.
We can go higher than 8.
12.
Oh, yeah.
12, right? We want to use the GCF, greatest common factor. 4 would have worked. 6 would have worked. But 12 is going to work better. So 1B, when I divide everything by 12, what do I get?
3P plus 1C plus
3P plus C plus 2. And then that's inside the parentheses. What's on the outside?
Is C the same?
12.
Yeah, same thing. 12. There you go. So it could be 1C. You could just put the letter C.
It's extremely easy.
And then 1C, right? So what is, according to example 1, what is Josiah doing with the pencils, crayons, and erasers?
Putting together a supply kit.
Yeah, he's putting together individual supply kits. So letter C, after we've factored, so we're gonna take this that I've kind of underlined in red. We want to take each term and figure out what this means within the context of the question. So if he's making supply kits, what of each item goes in the supply kits?
Pencils, crayons, or-
I know, but how many in each? Like, so how do I know what is in one supply kit? Foss? 3 packs of pencils. So what else? Keep going. So it's going to be not one, and then just 2 erasers. All right. So Foss is on the dot with that. So each kit, what is inside the parentheses, right? What is inside of here means that each kit, right? So I'll write this in words. One kit is going to have 3 packs of pencils. It's going to have 1 pack of crayons. And it's going to have 2 erasers. And then how many kits can he make in total?
12.
Yes, it's 12, right? So 12 kits. Isaac, I don't want to hear it. So
Per kid?
it's per kit.
Oh,
Per kit,
Yeah, I
right?
didn't say kid. I thought we were talking about a class.
So our original expression that I have up here in blue, this represents everything combined. It's as if he put in one bag all the crayons, all the pencils, and all the erasers, right? And then when you factor, you are dividing, right? So if you're going to break them up into different kits that have the same number of items in each kit, then your factored expression will show what each kit has. We divided all these pencils up into 12. We divided all the crayons up into 12. And we divided all the erasers up into 12, which means if he wanted an equal number of things inside the kit, each kit would have 3 packs of pencils, 1 pack of crayons, and 2 erasers. So again, factoring is just division, right? Factoring is just division. And then yes, the number on the outside means, well, I can divide it by 12, which means I can have 12 total kits. You guys all got that?
12 kids in total.
And that is represented by the number we divide by.
Is it because, like, whatever you divide by, that's what you have as rule?
Yeah.
Okay, got you. It's not very hard.
All right. So let's go to example 2. We're going to factor this expression. We have 15x squared plus 10x plus 5. These are some of my favorite equations. It's called a quadratic expression. Well, yes, and you'll use a quadratic formula to solve. So basically, what this is you have an x squared, you have just a normal x, and then you have a constant, right? So it's squared, x, no x. We're still able to factor them, even though we have different, I guess, types of letters. These right here, are they considered like terms? No, they're not. If you were to rewrite this would technically be 15x times x plus 10x plus 5. So why, huh? Yeah, you would just put squared, but that's what it is. So why, I want you to factor this expression for me since I can't combine like terms.
I put 3x to the power of 2 plus
Well, first of all, what do I divide by?
5.
Yes, you divide by 5, each term by 5. And then you got 3x squared plus,
So you never solve the square.
2x plus 1, and in parentheses outside would be 5.
there you go.
That's what I got. Yes,
Yep.
I got it.
So just to point out, you can't combine like terms unless they have the same exponent. If a number doesn't have an exponent, you can assume it has a 1 for an exponent. So every number has an exponent. It's the exponent of 1. You don't have to write it because if I have 5 to the first power, it just equals 5.
Who's the goat?
I'm gonna go.
Ross, how do we do 3?
You'll see.
Yeah, oh dear.
There's like nothing that matches 9 and 4.
I'm goated, bro.
No, man, oh, wait, Ross,
So
I didn't finish.
example 3 is kind of something that you're going to have to identify when you get to high levels of math. First of all, can we combine like terms? No, we can't. We have an A, we have a B, we have a C, we have different variables, so we can't combine like terms. Second, is there a common factor? I'll get him one. Actually, Panos, I don't have an extra one right now. You're going to have to just use, you'll have to use like a piece of paper, okay? All right. Sorry, Foss. I think you answered it. Is there a common factor? No. However, what does each term have in common? They have a negative, right? So when each term has a negative, what we're able to do is we're able to factor the negative out of the equation, which is going to help you out in the future because sometimes it's easier to work with positive numbers than negative numbers. So what you can do is you can actually divide each of these terms by a negative 1. And we're going to just reverse the signs by extracting the negative out of the expression. So negative 9 divided by negative 1 is positive 9. And then negative 4 divided by negative 1 is positive 4b.
Well, if we're saying 4b, then it's positive.
And then negative 13 divided by negative 1 is positive 13c. And then on the outside, what goes on the outside? Negative 1.
Oh, snap.
A negative 1. You could write it both ways. You could just write negative on the outside.
13 divided by.
You could just write that negative, or you can write negative 1. It's the same thing.
Well, no, just 9. Ross, but it wouldn't be,
Yeah.
none of them will be negative though, like on the inside.
Yeah, none are negative on the inside. We divide all by negative numbers. So this negative, and this negative turns into a positive, positive, and positive.
So if you divide two negatives, it becomes a positive?
Yes.
Like multiplying two negatives?
Yes. All right. Yeah. You guys? I'm excited for it.
I know, I'm excited for that.
For what?
I was excited after.
Put Fortnite.
I was excited for the first one, and afterwards it just like tired me. Unless it's a one day tournament, then I'm fine.
It's a one day. All right, so let's focus up. Xavier, quit talking. We have another expression. Let's go with no. Let's go with Giselle. Not only, so obviously Giselle, what number could you divide both by? You could divide by 4. But let's take another step further. It's not just a 4 we can divide this by. What else can we divide it by? Both these terms, are they positive or negative? They're both negative. So when all of our terms are negative, it's not just a positive 4 we want to divide by. We want to divide also by a negative 4, right? Yes. And again, it's just going to make your life easier. A lot of you guys like working with positive integers, and it's just going to help out. So Giselle, walk me through it. What would I get after I divide by negative 4? 1x. Ooh, not minus 7. A negative divided by a negative is a positive, so it's a positive. And on the outside, it's going to be a, not just a 4. What'd you divide by? Negative 4, right? We divide by negative 4.
Why do you have an O in the middle?
No, literally.
What?
28 and X.
That's a negative.
I circled the negative. Why? Decide, quit talking. All right, so let's get in the habit of factoring out the negative. On the test, I will have examples where you're going to have to factor out a negative. Xavier, dude, you shout out one more time. I got to give you a mark. I understand. What should you do if you have a question?
But then you're not aware.
Oh, I'm aware. Let's find out. Let's play that game. Yeah, Zoe. No, you can do it. So that's a good question. Zoe has a good question. I want to show you something I'm going to have in blue. So, if you see what's in blue, that's not an example in a note packet, but you can factor out a negative even though, like if I want this to be positive, I can factor out a negative 1 on both sides. And I could get negative 1 times 6x minus 8. So you can factor out the negative for just one term. Just know it'll flip the second term. So you can flip signs, and I'll show you that in a later example next week. But to answer your question, Zoe, no, they don't have to be negative. Now, we have an expression right here, and what's wrong with this expression right off the bat?
They're negative.
Not that they're negative. It's that, just because it's negative doesn't mean it's wrong.
You don't like terms?
Wesley? Letters are wrong. We want negative 6x minus 12y minus 18. Why is that?
Oh, I'm tripping.
Oh, alpha.
Yeah, we want alphabetical order, right? We want the constants at the end. Can we combine like terms?
Yeah.
No, we can't. So, Paxton, what can I divide all 3 terms by? It's not just 6. You're right. It is 6. Negative 6, right? So, negative 6 divided by negative 6 divided by negative 6. So, again, a negative divided by a negative is a positive. So, when I extract that negative 6, Paxton, what do I get? 1x
2y
plus 2y plus 3. And on the outside goes a negative 6.
Number 7. 6 or 7.
Awesome. So, that was example 5. Are we all kind of figuring it out? Give me a 1 through 5. 5, you get it, and could ace it on the test, and a 1 being you're speaking French.
What?
I literally speak.
All right, cool.
I'm
Plus,
learning
it's
French.
actually not very hard.
I'm literally speaking French. Just kidding.
We quiet.
The main character, man.
All right, so we have something else. This is going to be a little different. Right off the bat, are they like terms? No, they're not like terms. But what do both terms have in common? They both have, they can be divided by 5, but also x, right? So when you guys have this right here that I circle in blue, when you have 2 variables or 2 letters next to each other, what operation does that represent?
Division?
When 2 letters, well, multiplication. Yeah, multiplication, yeah. So when you have a constant and a variable or 2 variables like this, you assume that it's multiplication. So if you have variables that are being multiplied, you can actually factor out letters. Let me show you. So I'm going to multiply, or I'm going to divide not just by 5. I'm going to divide by 5x because both terms have an x. So here's what this looks like, right? My x's will cancel out because x divided by x just equals 1 because a number on top of a number is 1. Yeah, so when I factor this out, it's going to be 3 minus 4y. So I'm extracting the x out, and on the outside, it's not just going to be 5, it's going to be, nope, not negative 5, 5x.
So So Russ.
Oh, so
there's
now I'm
two-
factorizing the
Ross.
variables?
We're taking it.
Oh, and Wesley has a great point. Now that we took out the x, we still want to write it in alphabetical order, right? So it'd be 5x minus 4y plus 3, because you always want that variable in front. Now, in that context, Wesley, I would mark off points on the test, but both of these expressions are equivalent. They're the same thing. They're just written a different way.
Ross, do not take it out yet.
I will not.
Ross, so basically, there's two numbers and one of them has two variables.
The same variable.
Okay, say
The same variable.
they're all three of them are different.
If all letters are different, then you just work on the numbers. But if all terms have a similar letter, yeah. Josiah?
You mark us off if you don't kill the X.
Yeah, if I say like factor the expression and you don't take the x out, and you can, it'll be minus points.
Wait, we
Only
have
if you
to put-
can, though.
But the one you take out has to be on the outside.
Yes. Okay, close your Chromebook. All right, I want you guys to try example 7 on your own. It's kind of a challenge question.
They have like to them.
Exactly.
I don't like that.
I love it.
I'm not gonna try this.
It's their own
No,
number.
you have to be up for the challenge.
That's correct. Good job. All right, Isaac, face forward, no talking. X, face forward, no talking.
Okay.
I don't care. I'm gonna do the whole thing.
All right, so does anyone want to try to attempt? So first of all, are they technically like? Or do we have any like terms? No, we don't have like terms. We have x squared, we have x, and then we just have a, right? So technically, they don't have the same variable, or they don't all. You can't combine them, but they all share something in common. So what do all three terms have in common? They all have letter a. So what can we probably divide by? Divide by a. So if I divide by a, the a's cancel out, right? That just turns into a 1 because a number divided by a number is just 1. This a cancels out, that turns to 1. So, Panos, that's a warning. So we have 1x squared plus 1x, and then I have a question for you guys. Do I cut it off right there?
Yeah.
No, you don't. Because what is a number divided by a number?
One.
Or itself? Yes, it's 1. So it's actually plus 1.
That's pretty easy.
Wait, do
And then-
put 1x? 1x? I just put x.
You could do that. Yeah, that's fine.
You put? Yeah, because I don't. Yeah, can I just put?
You can't put a, and I'll show you. Because
Oh my God, bruh.
we got to put a on the outside because a represents a number. We don't know the number, but it's a number. So if you have a divided by a, it's just going to be 1 because a number divided by itself is 1. So you have to show it as 1. If you were to distribute this, right, you would end up with ax squared plus ax plus a, which is our original one.
Just do it, Ross.
All right, everyone stand up for the pledges. And that is your lesson.